Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Inert Possum by Chinstrap. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have a ciphered pointer sum, where clues outside the grid indicate the sum of all pointer cells of the row or column from the direction of the clue. A cell with a digit D in row or column X is a pointer sum if its distance in cells from the digit X in that row and slash column is exactly D. For example, if row 6 were 791653248, the row number is obviously 6. So we have to do everything in regards to that. Then 1 and 4 are pointer cells because the 1 is 1 cell away from the 6 and the 4 is 4 cells away from the 6. So therefore the sum of this row then would be 5. The pointer sum of this row would be 5 because the only pointer cells in this row are 1 and 4, and add them together, you get 5. Obviously, that's not going to work because Tn is a 2-digit number, but that's another point we'll talk to. So if the 2 were here, say, then this would be, okay, oops. Say the 2 were here and this was 3. Then actually both of these would become pointer cells because the 2 is 2 away from the 6, the 3 is 3 away from the 6 in that scenario. And then the sum would then equal 10 in this case for the pointer sum. So that's an example of how pointer cells and pointer sums work. Each of the letters from point represents a digit from 0 through 9. Different letters represent different digits, and all instances of the same letter are the same digit. So P will always be the same digit as a P somewhere else. An I will be the same digit as an I somewhere else, essentially. A question mark represents any digit from 0 through 9. And 2-digit numbers do not have leading zeros. Optional note space has been provided at the bottom. Interesting. So that's all we're given here. Huh. Okay. Two-digit numbers do not have leading zeros. That means one-digit numbers could have a leading zero. So the n could actually still be a 0 here. But P must match P here, which must match P there. That's interesting. Okay. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So I've done pointer sums one other time before. The sum of a row or a column can at most be the total of the sum of the digits 1 through 9, subtracting out the row number, and if the row number is not 9, a 9. So the reason why we do that, so first of all, 9 can never be 9 cells away from another digit, right? It's just every cell in the grid is at most 8 cells away from any other cell, orthogonally, or basically horizontally or vertically. So because of that, 9 can never be a pointer cell in any row or column. And in addition, obviously the digit number that's in the row or column. So in this case here in column 7, that would be 7. 7 can't be 7 away from itself, obviously. So that's why you know the max sum, max pointer sum in any row or column is 45 minus the row number. And if the row number is not 9, minus 9. So in column 8 or row 8, the max sum would be what? It would have to be 45 minus 8 minus 9, which is 28, right? 45 minus 17 is 28. In column 7, it has to be at most 29, right? Because it's minus 9, 45 minus 9, which is 36, minus 7, which would be, so for each one. So for column 9 and row 9, we are guaranteed that it has to be, it could be at most 36 because we subtract out the 9 for the pointer sum. For column 8 and 7, for column 8, it's 28 at most. Column 7 is 29 at most. Column 6, it's 30 at most. Column 5, it's 31 at most. For column 4, it's 32 at most. For column 3 and row 3, it's 33 at most. And then 34 for column 2 and row 2. And for column 1 and row 1, it's 31 at most. So we know O, P, and T have to then be 1, 2, or 3. And P can only be 1 or 2. O can be 1, 2, or 3, and T can be 1, 2, or 3. That means, so P has to be 1 or 2 here. T is 1, 2, or 3 here. That means none of the other I and N cannot be 1, 2, or 3. But they both could be 0. So 0, 4, 5, 6, 7, 8, 9 is allowed. If T is 3, that means N would have to be 0. And so that adds up to the maximum of the pointer cells. So how would that work? 6 and 9 obviously can't be pointer cells, but the rest must be. So 8 must be pointing at a 6. If this were 6, so 8 away from 6, either this is 8 and that's 6, or this is 8 and that's 6. But if this is 8 and that's 6, we need that to be next to 1 and 2, which is not possible here. So assuming T is 3, that would mean N is 0. O and P would be 1 or 2. We could not have 6 here. So 6 would have to be here. This would be 8. We'd have to have 1, 2, 3, 4, 5. That would be 9 and 7 there. So the 8 would be 8 away. The 7 would be 7 away. The 5 would be 5 away. And this L adds up to 30 for all of these work. So we know these would be 0. So we'd have 0 pointer cells in row 4 and 5. These would have to be 1 through 6, obviously. T we know would be 3. Remaining digits in this box would be 1 through 6. No 3 here, no 3 here. So that could work so far. Obviously, I is not 0 in that case. 4 and 5 would not be here. So we have 1, 2, 6, 7, 8, 9 there. And this would have to be 3, 4, 5, 7, 8, 9 there. Hmm. Um. What does this mean? That seems okay. So that's not too helpful. Do we have anything else? No, not really. Hmm. Hmm. Mm, That's not too helpful. What happens? The thing is, this is. I was hoping this would lead to a pretty serious contradiction, but right now it's not seeing anything there. Because the other one's much more wide open, right? So O being 30 something is fine. Um, hmm. I don't know, maybe. Hmm. Um, hmm, hmm, hmm. Um, okay, so what does happen though? What happens if O is 3? That means this is 30 something for the sum. At most, you're going to have 35. So that means 8, 7, and 6 are going to have to be valid pointer cells, right? If you don't have 8, 7, or 6, the most you're gonna if you don't have 6, the most you can have is 2 through 5 and 7 and 8, which is 29. So that's why 6, 7, and 8 have to be pointer cells. And for that to be the case, they must be pointing at 1. So 1 is on one end. So you're going to have 1 and 8, and then you have, so this can't be 1. That means P would have to be 20 something. Okay. So 2 would be here. That's not going to be pointing to the 1. So that means we can't have, so T has to be 1, which means this can't be 1 here. So this would be 8 away, that's 1, 7 away, 6 away. And the problem is we have a contradiction because 2 cannot be pointing at the 1. 5 can also no longer be pointing at the 1, and that's too many digits. So O cannot be 3. So therefore we do prove that way that T has to be 3, which means N has to be 0. Okay, there we go. So this is 3, N is 0. This can no longer be 0. T is a 3, so this has to work this way. Again, you can't have 6 here because that would force 1 and 2 have to be pointing at it, and then that would eliminate all possibilities for that digit. So we have to be pointing at 6 here with every digit except for 9. So that's 1, 2, 3, 4, 5, 7, 8, and this is 9. Oops. This is 9. So this is accurate. So we have 1 through 6 here, no 3 here. 1, 2, 6, 7, 8, 9 here, and 3 through 3, 4, 5, 7, 8, 9 here. Okay. Interesting. So N is 0. So we have 30 here. Oops. This is 30. N is 0. This is either 13 or 23. We're not sure which. This is either 22 or 11. Eight is not working for column 1. It's not going to be pointing at anything. Interesting. So if O is 2, P is 1. Can that work? O would have to be 20. Because 8... Actually, could that work? So if O were 2, P would have to be 1. Because they would be different digits. 1 can be pointed at, but this is only 5 away at most. So 1, 2, 3, 4, 5 away, or 1, 2, 3, 4, which would not be then 20 away, because 20 would have to include 7 away or 8 away. Sorry, 7 or 6 away. But we can't have either of them, because we have at most 5 away for the pointer cells to be pointer cells, which is guaranteed then to be at most 2 plus 3 plus 4 plus 5, which is 14. So no, O cannot be 2. P has to be 2. So P is 2, O is 1. That means we have 2 here. These cannot be 2. Remember 2, so 2 has to be in row 4, not pointing at a 4. So this cannot be 4 here. This is 22 then. Okay. So we have 22. This is 23. So the most this can be then, so the, in column 7, the most the sum could be is 29. Right? Because minus 9 and 7, 45 minus 9 and 7 is 29. So that means we must be missing 7, a sum of 7 for the digits, which is either 1 6, 2 5, 3 4, or 1 2 4 that we're missing for the sum of the digits. So 8 has to be pointing at the 7. So this must be a 8 on the ends pointing at 7 somewhere here, which eliminates 7 and 8 in the rest of the column. 2, no matter what, cannot be pointing at the 7 because it's 7's either here, which is 3 away, or 7's here, which is 1, 2, 3, 4, 5 away. So 2 is not working. So 1 could be pointing at the 7. So, okay, so that means we're missing 2 as a pointer value, as a pointer cell. We must be either missing 4 or 1 3 as a pointer cell. No. We're missing 5 or 1 4 as the pointer cell. So we're guaranteed 3 has to be a pointer cell. And this cannot be 3. 3 is guaranteed to be a pointer cell in column 7. So 3 cannot be here, pointing at a 7 here. So this must be 8 here. This must be 7, and this must be 3 as a valid pointer cell. That eliminates 3 in the rest of the box and row. 6 must be pointing at the 7 correctly. This is 6 away. 1, 2, 3, 4, 5, 6. So 6 is pointing correctly. 8 is pointing correctly. 5 is never going to be pointing correctly, so we're missing 2 and 5, which means 1 and 4 both must be pointing correctly in column 7. So this is 1. This must be 4 then, which eliminates 4 in the rest of the box. We have then 5 and 9 remaining in column 7. Okay, 3 eliminates 3 in the rest of row 4. This can't be 4, so where is the 4 in box 4? It must be here. This cannot be pointing correctly, so all of this is the value, and all of these, this is obviously green that going that way, but it has to be red going this way. So no 2 here. This can't be 1. That would be then a valid pointer cell. 2 away, 3 away, 4 away, 5 away, 6 away, 7 away. So this can't be 7. Okay. 3 is guaranteed to be one of these two. Okay. Okay. I cannot be 0. It's 4 through 9. Can't be 0, 1, or 2, 1, 2, or 3. Okay. So this is done. This is essentially done. So we don't care about column 4. We know this is column 1. This is satisfied for column 7. So that's done. This is 23. And we don't have an 8 pointing correctly. Right? 8 has to be at one of the ends pointing to the 9. Can we have it without 7? 23. So 30. So we have 36 to start with. 36 minus 8 is 28. if 7 was not a valid pointer, then that would already be 28 minus 7, which is 21 as a value, which does not work. So 7 must be valid pointingly. 6 must be valid pointing. Well, 6 can't be either of these. To point validly, we have to have 6 in one of these situations, which means 7 must be pointing validly here. This can't be 7 here, so we can't have 7 pointing that way there, so this must be 7 here, and this must be 6 here, pointing validly. So 7's pointing at 9. 1, 2, 3, 4, 5, 6, 7. So that's valid there. So this is 9, which eliminates 9 in the rest of the column. So one of these two is 9. Also, 9 eliminates 9 here, so that's 5 and 9 there. So we have 6 and 7. 1 is not pointing validly here, which means 4 also cannot be pointing validly. No, that's not true. 1 could be pointing from here. So 1, okay, that's not true. So we're either missing a 5 as a valid pointer, or we're missing 1, 4, or 2, 3. Remaining digits here are 1 through 5. Okay. No 5 here, no 4 here, no 3 here because of digits in the column. No 5 here because of digits in the box. No 3 here because of 3 in the column. Six eliminates 6 here. 8 cannot be here. 8 can't be here, so 8's one of these 5 digits. Remaining digits in box 9 are 1 through 4 and 7. No 1 here because of 1 in the column. This definitely has a 1 here at the start. This has to be invalid pointing to here, so this cannot be 5 here. Because 4 would then be pointing to 5 there, and that would be valid. 1, 2, 3, 4. So 5 is one of these 3, which is not helpful. If this were 5, that would force this to be 6, and this to be 1, and the 1 would definitely be 1 away from the 5, which would be valid as a point, which would make that a pointer cell, which cannot be because we can't have any pointer cells in row 4 and 5. 5, 6, 1, 3. That does actually kind of work there. Seven is not valid for column 2. Also, 8 is not valid for column 2. Because 8 would have to be either here or here, pointing at the 2 in that's 8 cells away. And so since 8 can't be here, and 8 can't be pointing to a 2 there, that's not going to be valid. So we have eliminated 7, 8, and 9, and 2 as being pointer cells for column 2. That's 45 minus 24, which is 21, minus 2, which is 19. Okay. Where can 2 be in column 2 then? Hmm. 7 doesn't point correctly. 8 doesn't point correctly. 6 doesn't. Okay, so what happens if neither 6 nor 4 point correctly then? If neither 6 nor 4 point correctly, we have at most 1, 3, and 5 as pointer cells, which adds up to only 9. So that's not possible. So 1 out of 4 or 6 must be pointing correctly. So if 4 points correctly, it can only point to 2 being here. If 6 points correctly, that's 1, 2, 3, 4, 5, 6. So 2 would have to be there. Okay. If this is 2, 5 cannot be here, and therefore 5 would not be pointing correctly. So you'd have to have 6, 3, and 1 pointing correctly, and 3 cannot be 3 away here, and there's no other 3 away that way. So 3 would not be pointing correctly either if this is 6. So this cannot be 6 away. It must be pointing to the 4 must be pointing correctly to the 2. So this must be pointing correctly. We don't have 6 pointing correctly, so that's invalid for column 2. 8 is not pointing correctly. 7 is not pointing correctly. So we must have 5 pointing correctly. So this must be 5. And we have 1 or 3 pointing correctly, or both. So one of these two must be pointing correctly to the 2. What we cannot have, though, is this be 1. If this was 1, the 1 would not be pointing correctly, and the 3 would not be pointing correctly. So this has to be 3. So we know this is 3 here, and that's pointing correctly. So we don't know about the rest. Okay, so all of column 2 is done. Well, essentially done. Again, for row 9, it's 7 and 6 are both valid. 2 means this can't be 2 here. Remaining digits in column 2 are 1, 8, and 9. No 1 here. 1, 8, and 9. Okay. The 4 is here. We already knew that, though. Okay, never mind. So we've eliminated all possibilities to making this any pointer cells. So no 1, no 2, no 3, no 4, no 5, no 6, no 7. Okay. 5 is either here or one of these two. If this were 5, the problem with that is that would force this to be, well, I guess 1 could be here and 6 could be there. So that's possible. Huh. Okay. 2 eliminates 2 in the rest of the row. 8 cannot be here. 5 in row 8 is not going to be a pointer cell because it can only point to that digit here, which is not an 8. 8 has to be either here or one of these three. Hmm. So 8's not a pointer cell. 2 still could be. 7 still could be. Hmm. Remaining digits in box 3. We have 2, 3, 4, 5, 6, and 8. Obviously, 6 cannot be any of these digits because of 6 in the column. No 5 here, no 3 here because of digits in the rows. Oh, 5 cannot be here. If 5 is here or here, the problem with that is 5 would no longer be a pointer, but then neither would this situation being 3 or 2 being here. So 5 cannot be either of these digits, which means 5 has to be here and must be a valid pointer. If this is not 2, that would mean so if this is not 2, it would force 1 or 4 to be there, which would then not be pointing at 9. But then we would not sum up to 23 correctly if this were not 2. So this must then be 2 here, 3 here. There are valid pointer cells, and these must not be valid pointer cells. So this cannot be 4 away, which means this is 1, and this must be 4. So no 4 here in the rest of the box. No 4 here in the rest of the column. 1 eliminates 1 here. No 2 here. Okay. So row 9 is done. So this is done. 22 is done. 30 is done. 0 in row 4 is done. This is essentially done. Okay. So we just have eyes here, here, here. Okay, remaining digits in box 7. We have 1, 3, 4, 8, 9. No 8s here. No 9s here. 5 eliminates 5 here. So this is 6, that's 1, this is 5. Okay. So that's good. No 1s here. No 3 here because of 3 in the column. This is a 4-8 pair, which eliminates 4 and 8 in the rest of the box and column. So that leaves these as a 2-7 pair here. Okay. We are guaranteed an 8 in one of these 2 cells. Remaining digits in column 1. We have 1, okay. 1, 3, 4, 6, and 9. Okay, no 1 here, no 9 here because of 1 and 9's in the row. Oh, these can't be 3. because of 3 in the box. 5 is not going to be a pointer cell. Can we have a valid sum if 6 and 7 are not pointing at the correct values? Well, 7. Okay, 7 is 1, 2, 3, 4, 5, 6, 7 away. So 7 is not a valid. So can we have it with... So if 1 were here, that means 6 would not be pointing at it correctly. We don't have 5, 6, 7, 8 pointing at it. And 2, 3, and 4 cannot be pointing at it correctly. And still be valid. So we have to have 6 pointing at it correctly, which means 6 can't be here. That's 1, 2, 3, 4, 5, 6, which would not be pointing at it. So 6 must be one of these two pointing at a 1 here. So this can't be 1. So this is 4. This has to have a 1. So it's not... This is 1 and 3, which eliminates 1 and 3 in the rest of the box. So this is 9. That makes this 8. That makes that 1. No 1 or 4 here. No 4 here. So we need 6 pointing at it and 4 pointing at it, because 3 is not going to be pointing at the 1 correctly. Neither is 2. So it has to be 4 away from 4. So 4 is valid as pointer, which makes this 1, which makes that 3. This is where it's pointing at. 3 is not valid, and 6 must be valid here. So this is 6, that's 9. 1 eliminates 1 here. 3 eliminates 3 here, so that's 7. No 3 or 7 here, it's 1. No 7 here, it's 2 or 3. So then column 1 is done. So we can delete the colors here. 5 is not pointing at 8. 1 is not pointing at an 8. 7 is not pointing at an 8. This must add up to not an I. Okay. This one. 1 away, 2 away, 3, 4, 5, 6, 7. So this can't be 7, and this can't be 8. So 5 eliminates 5 here, so that's 8. That satisfies that. So this can't be 8 here, no 5 here. It's 7 or 9. 8 eliminates 8 in the rest of the row here. 1 eliminates 1 in the rest of the row here. 6 eliminates 6 in the rest of this row here. So 8 is here. 1 is pointing at it, so that's fine. 7 eliminates 7 here, so that's 5, which makes this 9, which makes that 7. So 5 is not pointing at it. We have 1 pointing at it. 9 obviously doesn't point at it. 7 is not pointing at it. No 5 or 8 here. This can't be 4. This can't be 6. 6 is not obviously not pointing at it. So we don't know what that adds up to. Okay, remaining digits in row 8. We have 4, 8, 6, and 9. No 4 here. If this were 8, would any digit be pointing at it? 2 would not. 3 would not. 5 would not. 7 would not. 1 would not. 6 would not. So this would not. This would be 0, which is not possible. So this cannot be 8. This is 4, which makes that 8. 4 cannot be pointing. So this is 6, 8, and 9. That leaves this as 4, 5, 7. No 4 here. No 5 here. This has to be 5, right? Because 8 here has nothing pointing at it. 1 for these, 2 for these, 3, 4. 8 here would not have anything pointing at it. No 1, no 2, no 3, no 4, no 5, no 6, no 7. So 8 has to be here with the 2 and the 3 pointing at it validly. So then I has to be 5. 4 doesn't point at it correctly, neither does 8, 6, or 9. 5 doesn't obviously either, so this is a 5, which makes that 5, which makes that 5. 1 is already pointing at this correctly. This cannot be 1, this cannot be 2 pointing at it, because 1, 2, and 2 is not possible in column 8. So this must be 3, that's 2. This is not valid pointing at it. We need the 4 valid to be pointing at it. So this is 4, which makes this 2, that's 6. 6 is obviously not pointing at it. 2 is not pointing at it. So those are valid. So those we have proven. That's proven there. This is done here. No more 7. No more 9 here. No 2 here. So we have 3, 5, and 8 here. We need to look at 5 in column 5. Okay. It must add up to 5. So 6 and 9 cannot be valid. Remaining digits in row 1. We have 4, 5, 8, 9. No 5 or 8 here. No 4 here. What the heck is that? Ugh, I don't know. Sometimes the neighbors do some weird stuff. Anyways, I don't know if you guys heard that. Probably not. So, anyways, I'm just going to continue on. Remaining digits of row 2. We have 2, 3, 5, 6, or 7 available. No 5 here. No 3 here. No 3 here. No 2 here. There we go again. I mean, I don't know. Anyways, column 7's done, so let's delete those. Row 8 is done, so let's remove those. 6 or 9. Well, this has to be invalid either way, so it cannot be. So therefore, 1, 2, 3, 4, 5, 6. Well, we don't know that that's not 6 there, so that's not. 5 obviously cannot be 5 away, so it must be 3 away and 2 away, or 4 away and 1 away. And 3 is not going to be 3 away from the 5, so 4 must be 4 away from the 5, which means this has to be 5 there. So that means we need 1 away to be valid, and then every other cell to not be. So 5 eliminates 5 here, so that's 7, which makes this 4, which makes that 5. 5 eliminates 5 here, 5 here. 7 eliminates 7 in the rest of the column. This has to be valid and is 1, which means this invalid as 8, that's 9. That's not going to work. This has to be 6 then. And then this is 2. But then the 6 is pointing at the 5. Shoot. Okay, where did I mess up? Shoot, I hate this. This can't be 8. This is not going to be valid. 3 is not going to be valid. That means, yeah, it has to be 4 and 1. And 4 can only be valid here, so that's 5. Ugh. That makes a 7. Shoot. So 1 has to be valid here. But then this... That's so annoying. This can't be 1 or 7, so this must be 8. That's so annoying. This is annoying. Okay. I hate this situation. This situation really is it bugs me because it's like I know I'm really close, but I don't know where I made the mistake. And this one mistake, it's triggering everything else. So the question is, where did I make the mistake and where is it triggering it? Ah. Okay, we have to go through every row to basically try to figure out. Frick. That's so annoying. I hate that. Ugh. Column 1. Okay, this is the point thing to be pointed at. 6 away. 1, 2, 3, 4, 5, 6 is valid. 9 away, obviously invalid. 4 away. 1, 2, 3, 4, valid. 2 away, not valid. 5 away, not valid. 8 away, not valid. 3 away, not valid. 7 away, not valid. So that's 10. So that works for that. 2. 2 is here. One away obviously doesn't work. 8 away, nope. 5 away. Oops, this is not green. This is the pink. 1 away, 8 away, 5 away. Could this have been... No, it can't be 5 there. Okay, so that's why. So then that's green. 4 away, 3 away, 7, 9, and 6. None of those work. So that's 12. 3 away, 4 away, 5 away, 12. So that works. This is the problem, is 6 away is guaranteed to be there. So 1, 2... It has to be 4 away here is valid, but the problem is that that forces that to be 6 away. 22 from 7, 1 away, valid. 9 away, not. 3 away, valid. 4 away, valid. 2 away, not. 6 away. 2, 3, 4, 5, 6, valid, not valid. 8 away. So we have 6 and 8 is 14. Plus 3 and 1 is 4. 14 plus 4 is 18. Plus 4 is 22. That satisfies that. Ugh. 8 away. So from 8, we have 1 away. Valid. 3, 7, 9, not valid. 5, not valid. 6, not valid. 4, oh, I messed up this. Okay, well, there we go. So that's the scenario there. Okay, that's good. So that's good. We have to go all the way back until where we messed that column 8 up. So that's, okay, so that's the issue. That's not 3 away. Okay, there we go. Okay, there we go. So that's where we messed up. This is 4. No 4 here, no 3 here. It's 2, 6 as a pair, so no 2 there. Okay, so that's where we messed up. Okay, good. This cannot be 2 because this must be invalid as a pointer. This must be invalid, so this cannot be 2. That's 6, that's 2. Just to double check, 1 away works. 1, 2, 3, 4 away works. 2 away, 2 is not 2 away, it's 3 away. 6 and 5 obviously don't work. 3 is not 3 away. 7 and 9 don't work. Okay. This is satisfied. This is satisfied. Okay, so then colors. We can remove all these, so we just have to do column 5. Again, 5 cannot be 5 away from 5. So then it's either 1, 4, or 2, 3, adding pointing, and 3 is not valid. So 4 has to be valid. And remaining digits of, so let's do column 5. We have 2, 5, 1, 2, 5, 6, 7, 8, 9. No 1, 2, 8, 9 there. No 4, 5, 6, 9 there. No 1, 7. So 4-way has to be valid. So that can only be valid 1, 2, 3, 4. So this is what's pointed at, and 1 has to be valid. And 1 cannot be here, so 1 has to be there and is valid. So everything else must be invalid. So this must be a 5 here, which makes this 7. 9 eliminates 9 from being here. No 7 here. So no 1, no 7 here, that's 8. This can't be 5 or 8. 8 eliminates 8 here, so that's 7, which makes that 1. 7 eliminates 7 here, so it's 4, and that's 5. Obviously, this can't be 6. This can't be 6. So if this were 6, that would be 1, 2, 3, 4, 5, 6 away, and obviously that's not correct. So this has to be 9, that's 6. 9 eliminates 9 here, so that's 2. There we go. And this can't be 2 or 9, it's 6, which makes this 9 and makes that 2. 2 eliminates 2 here, so it's 7 and 2. No 5 or 8 here because of 5 or 8 in the row, so that's 3, which makes that 8, which makes that 5. And the rest is just normal Sudoku. We have 8 and 9 here. This can't be 9 because of 9 in the column, so it's 8 and 9 there. 4 and 6. That's 4, that's 6. We have 3 and 7. That's 7, and that's 3. So, besides this mess up here, everything was pretty straightforward. Execution on this is pretty difficult. The logic actually behind this isn't too bad. Execution, though, could be pretty hard. So, I think hard is an appropriate difficulty rating for this. Anyways, if you didn't make that mistake, good on you. Unfortunately, I did, so I was not good on my part. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.